Okay, so we had started with simplification of surds. And I think this sum we had done. Yes? 8 root 5 plus root 20 minus under root 125.
Yes, sir.
Okay. And one thing to keep in mind about surds, you can add only those surds which has the same number under the radicand. Correct? Only those surds you can add. And this one we did, right? So I'll skip this. Okay. So, and next is now multiplication. Now, to multiply two surds, there is no need that the radicand has to be same. Radicands can be different also. Only if you're adding or if you're subtracting any two surds, then the number inside the root sign, that is the radicand, has to be same. Then only you can add or subtract the surd. But in case of multiplication, there is no need for the radicand to be the same. Radicands can be different also. So now look at this case. It is root of 7 into root of 42. Now, first step is you can write the root as common for both 7 and 42. So I can give root sign common and then inside the radical sign 7 into 42. Okay. Now how much is 7 multiplied by 42? Can you tell me?
304.
Correct. 304. But we can do one simple way. This 42 is divisible by 7. 42 is divisible by 7. So what you could do is you can find out the prime factors of 42, or one simple way would be 42 is 7 into 6. So what this will do is it will make a pair of 7 into 7. So that is 49. And this root 6 is separate. We are just separating the root. Then you know square root of 49 is 7. So this becomes 7 root 6. Did you understand this?
Yes, sir.
Okay. I want you to write this down. Please, can you see subtitles?
Yes, sir. Done, sir.
Okay. Now, in the exact same way of multiplication, you can even divide two surds, and same way to divide two surds, the radicand need not be same. It can be different one. So let's divide this third. So we'll divide root of 125 upon root of 5. One second. Huh? Okay. Yeah, we'll continue with this. So here we have to divide. Okay. So under root of 125 divided by root of 5. Now, in same as we did in multiplication, you can take the common root. While dividing also, you can take the root common for both the numbers. So I'll take the root common. It will be 125 upon 5. Now it is possible to divide 125 by 5. Yes? So let's do the cancellation. 5 ones are 5. 5 twos are 10. 2 borrowed. This became 25. So this becomes 5 fives are 25. So it is under root of 25. And you know, square root of 25 is
5. 5.
5. So this is 5. So under root 125 divided by root of 5 is 5. The answer is 5. Did you understand this? So 2 points to keep in mind when you're doing multiplication and division of surds. So when you do multiplication and division of surds, the radicand need not be the same. But when you're adding and subtracting two surds, the radicand has to be same. Then only you can add or subtract it. But for multiplication and division, you can directly take the radical sign common and multiply the numbers inside. Is it clear? Okay.
Yes, sir. Yes.
Okay, I want you to write this one. Write down this.
Done, sir.
Okay, can you do this one? Root 50 into root 18. Write it and do and tell me the answer. Yes, did you finish? Why are you taking so much time? Multiplication is easy, you just have to multiply 50 into 18.
Yes, I forgot. I
Or in simple, you just have to multiply 18 with 5 and just put a 0 to it.
Nine hundred.
900.
900.
900 you got, now correct. 900 is correct. Square root of 900 you got. But don't you think we can reduce this? 900, we can write it as 9 into 100. And now you separate the root 9 into root 100. And you know square root of 9. What is square root of 9?
3.
And square root of 100?
10.
And 3 into 10? 30.
30.
Your final answer, square root of 900 is 30.
30.
Write down this also. After root 900, write these steps. Let me know once you finish writing.
Done, sir.
Okay. From this example, you should note one thing, that multiplying two surds or dividing two surds can give you a rational number also. Okay, multiplication of two surds and division of two surds, it can give you an irrational number also, like the previous example, and it can give you a rational number also. Okay, keep that in mind. Not necessary that two, as you know, a surd is an irrational number, and it is not necessary that if you multiply or if you divide two irrational number, you can get a rational number also. But in case of addition or subtraction, you add two surds, you will get a surd. That means if you add 1 minute. Okay. But when you are adding or when you are subtracting two surds, that means two irrational number, your answer will also be irrational. But in case of multiplication or division, it can be both. It can be rational or it can be irrational. Is it clear? Okay. Now, next very important concept is called rationalization of surds. Okay, let's understand what is rationalization. Now, if the product of two surds is a rational number, like the previous example, the sum which you solved, if it is a rational number, each surd is called a rationalizing factor of the other surd. So let's see with a very simple example. If the surd root 2 is multiplied by root 2, what should be the answer? Like this. If you multiply root 2 with root 2, what will be the answer?
Root 4.
And what is root 4? Square root 4. Root 4 means square root of 4. So what is square root of 4?
2.
2. 2.
2.
2. So if, as you said, root 2 into root 2 will give you root 4, and square root of 4 is 2. And note that 2 is a rational number. Okay? 2 is a rational number. So you are multiplying this surd with another surd and you get a rational number. So this number or this surd which you are multiplying it with is called as a rationalizing factor. Understood what is a rationalizing factor? I am multiplying this surd root 2 with another surd that is root 2 only, and I'm getting a rational number that is 2. So this root 2 will be called as a rationalizing factor of this root 2. Did you understand?
Yes, sir.
Now, rationalizing factor of a given surd is not unique. Okay, one surd can have different rationalizing factor. So let's see, for example, square root of 27. Okay, square root of 27. Okay. 27, this surd can be reduced. You can either find out prime factors. So 3 9s are, 3 3s are, 3 1s are. So what will be the reduced form of this surd? Can you tell me?
3.
Just 3? Make a pair.
Root 3. Root 3.
Only root 3?
3 root 3. 3 root
Correct. 3 root 3. 3 root 3. Now, If you multiply 3 root 3 with root 3, what will you get? Can you tell me?
$27.
3
27, sir.
into, now this is in the root sign and this is also in the root sign. Take it common. 3 into 3.
Yeah.
Correct?
Yes, sir.
Equal. 3 into, inside the root,
9.
3 into 9. And what is root 9?
3.
And this 3 as it is. So 3 into 3.
How many points in the graph?
9.
How many points? Just X and Y.
Okay. So this is 9. 3 into 3, 9. Correct? Now, if you note one thing that for the third 3 root 3, you multiplied another third root 3 and you got the answer 9, which is a rational number. Okay, this is a rational number. So this root 3 is called as a rationalizing factor of this third. Did you understand this much? Okay.
Yes, sir.
So root 3 is a rationalizing factor of root 27 or 3 root 3, one and the same thing. Now note that root 27, that is 3 root 3. If you multiply 3 root 3 with itself, with 3 root 3 only, what will you get? Can you do this multiplication and tell me what will you get? Write and do. If you cannot do it, or write it and do.
The answer will be 9 root 3.
9 root 3.
9
do the-
root 3.
Let's do the calculation. 3 root 3 into 3 root 3. First, we'll multiply this 3 and 3, write it together. 3 into 3
9.
into, and now this root 3 into root 3. So root 3 into root 3. So this is 9. And here you can take the root common. So it will be 3 into 3. So 9 into root of 9. Correct? Now next, 9 into what?
Root 3.
Root 3. Root 3. Or just 3. What is square root of 9?
Square root of 9. 3.
3.
Yeah.
So 9 into 3.
27.
And 27 is a rational number. Correct? So you see, 3 root 3 are multiplying it with 3 root 3. So this becomes the rationalizing factor of 3 root 3 or root of 27. So you see, look at this. Here, root 3 is a rationalizing factor of 27. And here, 3 root 3 is a rationalizing factor of root 27. So you see they are different. So one third can have different rationalizing factor. Did you understand this? Okay.
Yes, sir.
I want you to write this down. Write it down. And any doubts, Chris? Okay. Write it down carefully. Understand each step and write it down. If you have any doubts, you can ask me. Now, rationalizing factor is clear. What is rationalizing factor? Yes, with a third, if you multiply another third, and if the answer is a rational number, then we call that to be the rationalizing factor. If the answer is irrational number, then what will you call it? Then will it still be a rationalizing factor?
No, sir.
No, no. Answer has to compulsorily be a rational number. Then only you can call it as a rationalizing factor.
Done, sir.
Now here, the next concept is rationalizing the denominator. So we have a third here, a irrational number, 1 upon root 5. Now, rationalizing the denominator means in the denominator here we have an irrational number. And rationalizing it means we have to convert this irrational number into rational number. That means there should be no third in the denominator. Did you understand what we have to do? What is the meaning of rationalizing the denominator?
Making the denominator rational.
In this case, we will have an irrational number, or basically a third in the denominator. And you have to convert that irrational number into rational number. And that is called as rationalizing the denominator. So what is rationalization? Is that clear? Basically converting irrational to rational, but in the denominator. So an irrational number can be in the numerator, but not in the denominator after converting. So let's see how to do this. So to convert, to rationalize this, what you do is you have 1 upon root 5. This you have to multiply and divide with the third that is in the denominator. So root 5 is in the denominator. So you multiply and you divide with root 5 with the same third that is in the denominator. Is this clear? Okay. Now, these are two fractions. So you know how to multiply two fractions, numerator with numerator, denominator with denominator. So 1 into root 5 will be root 5. And in the denominator, you have multiplication of 2/3. That is root 5 into root 5. Equal to numerator as it is. In the denominator, what will happen? Can you tell me?
Root 10.
10? How 10?
5 plus 5. 5 plus 5.
No. We are not adding. See the sign.
Yes, sir. Yes.
So what will happen?
25. Root 25.
Yes. Root 25. Understood? Yes or no? Okay. And what is
Yes,
root?
sir.
What is root 25 or square root 25?
5.
5. So you see, we have rationalized the denominator, and this is root 5 upon 5. So you see, the denominator now has a rational number. It's okay if the numerator has an irrational number, but we are rationalizing the denominator only. Did you understand this? So,
Yes, sir.
so to rationalize the denominator, you multiply and divide with the same third that is in the denominator. Okay? Is it clear? Write down the sum.
Yes, sir.
Write down the sum. And at this point here, write multiplying so at this step, right, multiplying and dividing by root 5.
Done, sir.
Okay.
I'll send you the PDF.
Okay. Look at the next one, rationalizing the denominator 3 upon 2 root 7. So you have to do the exact same thing, 3 upon 2 root 7. Now multiply it with, you have to multiply it with only the third. Okay, multiply only the third in the numerator and the denominator. So which is the third in the denominator?
2 root 7.
Only the third, that is
Oh, root 7.
root 7. So you just multiply and divide with root 7. So root 7 upon root 7. Okay, so I'll write here multiplying and dividing by root 7. Okay, only the third. That 2 I haven't taken because that doesn't have a radical sign. So only the number which has a radical sign. Now this is two fractions. So you multiply numerator with numerator, denominator with denominator. 3 into root 7 will give you 3 root 7. Correct? And denominator will become 2 root 7 into root 7. Now numerator will write as it is 3 root 7. Denominator will become 2. Can you tell me next? 2.
2 2
First,
root 49. 2 root 49.
48 or 49?
49. 49.
49. 2 root 49. And what is square root 49?
7.
7. So this becomes 2 into 7. And that is 2 into 7 is
2.
2
14.
7s are 14. So the denominator becomes 14. So it is 3 root 7 upon 14. And if you see, the denominator is rationalized. That is, now we have a rational number in the denominator. Is this clear? Write it down.
Done, sir.
Okay, now we'll start with practice set 2.3. So now you know how to add two surds, how to subtract, how to multiply, how to divide, and how to rationalize the denominator. Okay, so our entire exercise 2.3 is based on all these concepts. So question 1, state the order of the surd given below. What do you mean by order? Do you remember? If it is a square root, then the order is 2. If square root, then the order is 2. If it is a cube root, then the order is 3. Correct?
2. Yes, sir.
If it is fourth root, then the order is 4. If it is fifth root, order is 5, and so on. So for the given surds, you have to just tell the order. So let's see the first one. First one, can you tell me what is the order? Unmute yourself. For first one, this one. What is the order?
3.
3. Correct.
3.
The order of the surd is 3. For the second one, what is the order?
5.
5 is
5.
not. 5 is just a number before the surd. It is square root 12. 5 square root 12. So what is the order?
5 square root 2.
This 5, it's not fifth root of 12. It is not like this. It is not like this. It is like this. There is a difference between this. Okay, if I say if it is like this, this means fifth root. Well, this is 5 into root 12. So what is the order?
2.
2. Correct. 2. The order of the surd is 2 for the second one. For the third one?
4.
Correct. 4. Next, for the fourth one?
2.
Correct. And last?
3.
3. So the order of the surd is 3. So now you know how to identify the order. Okay, don't get confused between these two. Okay, these are completely different. When the number is on the radical sign like this, then you say third root, cube root, fourth root, fifth root, and so on. But if it is besides it like this, then it becomes multiplication, like 5 into root of that whatever. Is it clear? Okay.
Yes, sir.
This you can write it later on. You already know how to do this, so write it afterwards. Okay, in question number 2, you have to state which of the following are surds, and you have to justify. So you have to identify which is a surd or not. So let's start with the first one. First one is root of 51. Is this a surd? Cube root 51. Cube root of 51. Is it a surd?
Yes, sir.
Yes, it is a surd. If you try to find prime factors of 51. So it will be 3 ones are 3, 3 sevens are 21. 17 is a prime number, so this becomes 17 ones are 17. So this will become cube root of 3 into 17. And if you, while multiplication, you can separate the roots. So in this case, it is cube root. So you can separate cube root. Cube root 3 into cube root 17. Now, cube root 3 is a third. Yes or no? Cube root 17 is also third. Both of them are third. And when you multiply them, you will get cube root 51 back. Therefore, this is also a third. Okay, so cube root 51 is a third. Did you understand this?
Yes, sir.
Okay. Will you write it down later on?
Okay, sir.
Or you want
I'll
to
write
write
it
it
down.
now? You want to write it right now?
I can write it down later. I can write it down later, sir.
Okay. Next one is fourth root of 16. Is this a third?
Yeah.
Yes, it is a third.
Yes, sir.
Can you think? Let's start by finding prime factors of 16. Okay. 2 8s are 16. 2 2s are, 2 4s are 8. 2 into 2, 4. And 2 into 1, 2. So look at this. 2 into 2, 4. 4 into 2, 8. And 8 into 2, 16. So this I can write it like this. 2 into 2 into 2 into 2. So this you can write it as 2 raised to 4. Correct? 16, you can write it like
Yes,
this,
sir.
and this is 2 raised to 4. So look carefully. 2 raised to 4 is equal to 16. Okay, so this power here is 4. This means that fourth root of 16 is 2. Did you understand this? We'll take, okay, I'll explain you with a smaller number. You know that 2 square is 4. You know this? And then square root of 4 is 2. So look at this. This 2 means square root. So this comes here. That means square root of 4 is 2. Let's do some simple one. Look at this example here. 3 cube is 27. Correct? That means cube root of 27 is 3. Understood this?
Yes, sir.
So now look at this. 2 raised to 4 is 16. That means fourth root of 16 is 2. Do you understand? Now tell me, is this a third or not a third? If it is a rational number, it is not a surd. So what is it?
It is a surd.
No, it is not a surd. You're getting the answer. What is a surd? Irrational number. An irrational number is a surd. Correct? But
Yes,
here,
sir.
fourth root of 16 is a rational number. So will it still be a surd?
No, sir.
No, I think you're confused between the definition. You have forgotten, I think, the definition of rational, irrational, and
No,
surd.
sir. No, sir. I'm just confused because I thought that because I thought that symbol made that irrational.
Okay.
Yeah.
Okay. This thing. Oh, the symbol made it irrational. But the answer,
Yeah.
you get. Look at the answer to identify. Look at the answer. Sorry, I wrote 2 here. This 2. Sorry. So to identify, just look at the answer. The answer is a rational number. That is why you can say that this is not a surd. Is it clear? Now for this,
Okay,
we are
sir,
getting
now.
an answer. For this, we are getting an answer. But if I say cube root of 3, you're not getting anything, right? You will get, if you do by the division method, you'll get some non-terminating, non-recurring number, something you'll get. So that is why this is still irrational and this will still remain a surd. Understood the difference?
Understood, sir.
Okay. So fourth root of 16 is not a surd. Let's see next one. Third one. Fifth root of 81. Okay, fifth root of 81. First, let's try to identify by finding out its prime factors. So it's divisible by 3. 3 2s are 6. Here borrow 2. 3 7s are 21. 3 9s are 27. 3 3s are 9. And 3 1s are 3. So that means 81 is equal to 3 into 3 into 3 into 3. That means this is 3 raised to 4. So you can say 3 raised to 4 is 81 and fourth root of 81 is 3. Correct? But here what it is? Fifth root it is. So can you tell me, will it be a surd thing? Will it be a surd or will it not be a surd?
It will be a surd.
It will be a surd, correct. So root 80, fifth root of 81 is a surd because fourth root of 81 is a rational number. If it would be fourth root of 81, then you would say it is not a surd. Yes? If this question, instead of 5, if it would have been 4, then what your answer would have been?
It would be a surd.
It would be a
It would not be a surd. It would not.
Yeah, sorry, it would not be a surd. It would not be a surd. Clear? Okay,
Yes,
let's move on to the next one. 256, square root 256. So this is not a surd. Now let's see why. You first try to find out prime factors of 256. So 2 1s are 2, 2 2s are 4, 2 8s are 16, 2 6s are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4, 2 1s are 2, 2 6s are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4, and 2 1s are 2. Did you understand this prime factorization?
yes, sir.
So that means just count the numbers of 2, 1, 2, 3, 4, 5, 6, 7, 8. That means 2 raised to 8 is equal to 256. Correct?
Sir, you're on mute.
Okay.
Sir, you're on mute again.
2 raised to 8 will be 256. Correct? So 2 will be equal to 8th root of 256. Yes? Now if you look here it is not given 8th root. It is just given square root. It is just given square root. So you'll have to do some changes, little bit of changes.
Sir, you're on mute.
I think there's something wrong with my laptop. That's why I'm getting muted again. Okay. You know, square of 16 is 256. Correct? That means square root of 256 is 16. So that is why, and 16 is a rational number. That is why 256 is not a surd. Is this clear?
Yes, sir.
Next, fifth one is cube root 64. Now, cube root 64 is also not a surd. Let's see why. First, you find out all prime factors of 64. So 2 3s are 6, 2 2s are 4, 2 16s are 32, 2 8s are 16, 2 4s are 8, and 2 2s are 4. So we are getting here 1, 2, 3, 4, 5. 2 raised to 5.
No, sir. No, sir. 6. Sir, 6. You in the last
Okay,
one, sir.
one I missed. One. Okay. So 2 raised to 6 is 64. That means 6th root of 64 is 2. But in the question, it is said cube root. Cube root. So for that, if you see, we'll have to take some other number. So we can rearrange this itself. So you got 64 as 2 raised to 6. You can rearrange this to 2 into 2. Make it a pair of do pairs. So this is 4 into 4 into 4. That means 4 cube. So 4 cube is 64. And you can say that cube root of 64 is 4. Correct? And 4 is a rational number. That is why cube root 64 is not a surd. Is this clear?
Yes, sir.
Okay, we'll stop here. We'll stop here. The 6th one we'll do in our next class. So your homework will be whatever sums we did today, which you wrote, you practice it again, and the 2.3, question number 2. 1 and 2, you have to write it. Okay, I will upload the recording also. Today itself, I'll upload the recording. Okay, so view that recording and write all the sums. Fine? Okay, now see you on Tuesday.
Bye, sir.
One more thing, if your mom is coming to the school tomorrow, send your notebook with her where you have done your previous homeworks.
Okay, sir.
Okay, just ask her if she's coming, then you send your notebook. And even the test where you wrote the test, that also sent.
Sure, but I use two separate notebooks. The one for where you, that two separate notebooks. The when you tell me to copy the second sum, sir, I use the second rough book, and when you ask to do the homework, so I do it on that on the other book, sir.
Okay. So wherever you do your homework, that book sent.
Okay, sir.
Okay.
Sir.
Okay. So see you on Tuesday. Bye.